Hey guys, this is our last video for this semester, and it's been a good summer. So I'm going to jump into the project because I have a lot to talk about. Um, in this project, we were supposed to design a product for Park University to manage their bike share system. The share system I've created would be utilizing um, three major components: the bike, the docking stations, and the user. And this is all going to be tied together using Ethereum and that cryptocurrency network. They're much more than just a cryptocurrency. They will also do data warehousing, and they do data analytics, and they do app creations, and actually have software development potentials there as well. So, what needs to happen for this product? First of all, we have to have a GPS transponder for every bike. So every bike will have its own transponder. By virtue of having a transponder, that means it will also have its own unique ID. And so we can tie every bike to its physical location across Kansas City, technically around the globe, but I doubt these will be going to Mount Everest, so Kansas City. Um, and the docking stations will have charging stations to charge up the lithium-ion battery backup for these bikes, and also the bikes will be utilizing, the whole energy creation through braking and through pedaling. So the battery should stay charged for at least 18 hours a day without going to a docking station. That's the whole purpose behind the lithium-ion battery. The docking stations will be very simple, straightforward. You're going to have a panel on one side, just like at normal bus stops, for adverts and for the map and to show where the bikes are located. Just a lot of different things that can go through there, but mostly to draw attention to the bike station and to give rudimentary information to the person. There's going to be a docking station, again, a maglock for each bike, and it's also going to have a charging potential in that bike. It's going to be connected to the power grid so it can charge. It will also have its own independent power supply in case the power cuts out, and it's going to have its own internal database containing all the ledgers. So if we have an internet down situation going, uh, the program itself will be able to forecast where bikes might be located or what might be available based upon previous ride data. Um, so that's what's going to be housed at the docking stations, just a terminal for the person to interact with, the user to interact with, to log in, to create a login, to rent a bike, to park the bike, to sign up for the app, all that fun stuff. The application itself is going to be uh, on the system itself, on each docking station, also on the phone. Going to be linked up to the Etherium network, and that network itself. What's really interesting about it is that it is using the latest technology in security authentication, and those security protocols have not been cracked. Their major threats are on the financial side. And the financial side is strictly, we were talking about the cryptocurrency, not with the data itself. We're talking about data manipulation for the purpose of duplicating essentially Bitcoin or Ethereum. Um, and those attacks have happened, but they have not happened on the data side because there isn't as much financial interest in duplicating those kind of transactions. What needs to happen to make this program launch? First of all, we have to get the hardware in place. So the bikes, the maglocks, the lithium-ion batteries, the docking stations, that whole thing has to be built. But from an IS position, we need to have authentication with Ethereum, create an account with that network to begin app development. And when that app development is complete, we can have it, we would create apps that could be placed into the Google Store and into the Apple Store, and they would automatically have interactions with the main database. There wouldn't have to many. You wouldn't have to do as many um, requests, API setup, because it would be inherently connected to the network because of your authentication. So those APIs that you normally see with a normal app, you wouldn't have to do because Ethereum will have its own currency that things can be processed through. I mean, in the end, you're going to have some sort of APIs if people are trying to use their own credit cards, but in theory, you could have your own closed circuit system where you don't require outgoing data to be authenticated using a traditional API source, because the hash code from each transaction will be its own authentication. It doesn't need to have that same kind of push and get that most programs require, because the when the information reaches the servers, if the hash code's authenticated, they don't read the transaction data from that hash code, and that's it. That's the end. So pulling that information is easy, because all ledgers on cryptocurrencies are available for everybody to see. You just have to have a decryptor to be able to actually read that data. You can maintain the ledger and see the ledger and confirm the ledger, but you don't really understand what's going on there. And since that's the case, those files will be on the app itself, so you can definitely see what's going on, and it allows for faster processing. It's going to be mostly done on the client side than it will be on the server side, but then also the server can do all the work itself. So it's kind of a two-way system. What's really interesting about these kind of systems is that every user or part of the network is doing part of the processing. So it's not like one user is doing it just entirely themselves. They're relying upon everybody a part of the network. The more members are a part of the network, the more powerful, the faster, and the more secure the network is. That is one of the most unique attributes to these kind of secured networks. So, and what's crazy with these secured networks, because they're coded in such a way that you don't actually have to be on a VPN, because you don't need a VPN. All the data is encrypted. You have to have a decryptor to kind of gather your information. And those decryptors, they are created in such a way where they don't release out the permanent information, the pertinent information. They just say, oh, is this key authenticatable? Yeah, we see these portions of it, so we're going to decrypt the parts that are important, and then send all the rest of the information to the main mainframe to handle the information, to handle the data, to actually process it, that sends out to everybody else. It's a very unique system. So when we're talking about the development stages of this in the from an information systems process, really it's going to be mainly app development on the Ethereum side, and that's going to be distributed through everybody's phones and through each station. And those station points are going to be, it's pretty straightforward. We're talking like a Raspberry Pi can run this, and a very small hard drive can run this. A terabyte hard drive, which would not be inconceivable to have, would last for years on these systems, and they would be rarely used, because most of the information is going to be transmitted directly to the server to handle through their hash codes, which is literally just bytes. It's not that much information that's being projected, because it doesn't need to be. So that's a very unique feature of these databases, is that you don't have to have a constant refresh rate, a constant up and down between server and client, when the client's just reading the information. So that, I think, presents a very unique opportunity for this business plan and for this product. I'd like to hear your thoughts about it. So yeah, any criticism is good criticisms. Thank you.